Hi everyone. So for the demo part, we're going to practice with files, throwing and creating our own exceptions, handling exceptions, and also writing some unit tests. So it's a bit of a mishmash, but since we're talking about things that could potentially generate a lot of errors and exceptions, handling those exceptions makes sense, and then also testing for proper operation of your code also kind of fits in with the theme of that lecture. So first of all, let's get started by doing some basic file input and output. So we're going to start with some basic data. Imagine I have some student data. So first of all, what I'm going to do is I'm going to put everything in a format that where none of the values are put together. So let's say I have Alexandra, and I have Charlie, and I have lead, and then I have some student IDs. And let's make these strings as well, even though they're mostly numeric. So I'll just say we'll have a 9-digit number. There we go. And marks. These will be floating point, let's say. Let's say Alexandra has 75, 45 for Charlie, and 90 for Helen. And of course we can compute the grades manually, but that's not what this lecture is about, so I'll just enter in their grades. Let's call a 75 a B, let's call a 45 an F, and let's call a 90 an A. Okay, so let's put all of this stuff together into the file. I'm going to open up a file, and we're going to output the data. So I've got a sample file already here. I should close some of these old files. This is what I'm hoping to see, something like this. And I just have a data directory to keep things a little bit cleaner. So what I'm going to do is I'm going to say with open, then we're going to specify the file name, and the method that I want to use is going to be write. So I'm going to call this as output file. Let's pass for now. Excuse me. Okay, so in our data folder, we're going to have, it's called classlist.csv, so let's call it classlist output.csv. The CSV just stands for comma separated values. It's kind of a file that we've got here. So you can see there's commas in between the values and a new line in between each student entry. I've got another alternative format here called JSON. We'll output to that momentarily. So all I'm going to do then is I'm going to go through the indices. Let's just take the length of one of these, the names list, let's say. And all I'm going to do is say output file.write. For simplicity, I'm going to write an F string. So we'll print the student IDs, then the names, then the marks, finally the letter grades. I'm just going to say student IDs at index I, names at index I, marks at index I, and finally grades at index I. Okay? Now this with clause, if you remember, what it does is it creates this output file variable here as a local scope. So normally this would be a global variable where I'm currently writing it. But what it's going to do is going to create a scope that only exists, this output file variable only exists for the context of these two lines. So after these two lines are done executing, Python is going to garbage collect that object, which will close the file automatically. That's just how Python works. So let's give that a try. Okay, so we'll save that, and we'll run it. And it seems like we're actually in the wrong folder here, because it looks like we're directory where we're supposed to be here is in the Random Videos folder. So just correct that by putting in demos in front of that. Should solve that problem. One important thing is when you're in Visual Studio Code, the location where the file isn't necessarily the location where it runs. Because I have it's called Random Videos folder here, that's what it uses as the current directory when it's running the program, even though this program is within a subfolder. So to access this file, I need to specify a file name relative to the current path. So there we go. Anyway, it runs, and you can see now we have this class list output here. You can see that I have a typo in my program because that's not what I wanted. I actually wanted something like this with new lines in between. And that's an important thing to note here, is that the right here doesn't actually add any special characters. So print, when you're in Python, print automatically adds a new line at the end. I need to be explicit and write a new line in here. So let's run this one more time. Okay, so now opening up this file, I kind of changed that. So let's delete the file actually, so we can be absolutely sure that our program is generating the right content. So run the program. There's our file again, and our file looks okay. Okay. Anyway, so let's read that same file. We'll use the with open again, and I'm going to call it input file this time. And again, open always takes two arguments. We have the file name and we have the mode. I'm going to open it up for reading this time. Okay, so let's put in the correct file name. And then all I'm going to do is I'm going to loop over it. So I'm just going to say for line in input file. And Python will allow us to do that because this input file is an object, but it represents the connection to the file. So if I iterate over that, it'll give me one line at a time. So all I'm going to do is print line. This is also going to show somewhat of a quirk. So when I run this, you're going to see that there's an extra new line in between. And that's mainly because, of course, print prints a new line at the end. But line also includes a new line because in the actual original file, there's a new line at the end of each line. So that's included in line here. But I can suppress the one that print generates just by setting the end parameter. I think we've talked about this before. The end parameter normally contains a new line. This is what it's going to print at the end of printing all of these variables. This is just one variable. I'm just printing line, but you can have a list of variables, comma separated here, passed to print, and it'll print them all by default with a space in between, but you can override the set argument in order to change that to something else. And then at the end, it puts the whatever is in the end parameter. Normally that's a new line. So if I set that to empty string, it will no longer print that new line. It'll only print the new line that's in the file itself. And of course, I could strip out the new line in the line and just print it normally if I wanted to. That's another way to solve the same problem. Okay, so comma separated values is a pretty common file format to be used, especially in data science. There are a lot of open data sources out there provided by governments and so on. And one of the formats that they use, probably not the number one format, but I would say the top three formats are comma separated values, XML, and JSON. And so this data is usually available in one of those formats. There are also some open data portals that provide their data in like Excel spreadsheets and stuff. And obviously reading those files in is going to be a lot more complicated. But reading in a CSV file is kind of the easiest one because it's sort of like no nonsense. There's no excess data in here. It's just sort of like separators, the minimum separators that we might need in order to pull our data back out. And by the way, if you open this up in Excel, it would actually open it up as a spreadsheet. Can't have any formulas or anything fancy like that, but it recognizes this format. The only thing that makes it complicated is if you have commas in your actual data. So if you have something like a name and the name has like last name, comma, first name, or if you have an address that has a comma in it, that could be problematic here. So you have to make sure you put quotes around those strings, which we're not doing. All right, for the other type that we mentioned, XML is a little bit beyond the scope of this class, but JSON is a relatively simple format. I'll show you an example of a JSON file here. This grades file here, and you can see that it kind of just stores, in this case, just a dictionary, just a single dictionary. And anyway, all basically it is a list of student IDs and a letter grade. So that's relatively straightforward. And it just so happens that this is also like valid Python syntax. But JSON is so named after JavaScript, but it happens that they both are compatible with one another. So I think what I'm going to do for simplicity, first of all, I need to import the JSON package, which has the library functions that I'm going to use. And then I'm going to say grades is equal to, and I'm just going to copy and paste the value from that file. But to make this a bit more readable, I think what I'll do is I'll put each one of these entries on their own line. And that's just to save me some typing, so you don't have to watch me type out a bunch of student IDs and grades. So I'll put an extra comma at the end. We've talked about this before. That way, if I ever wanted to reorder these things, I could do so quite easily. So in this case, I've got a dictionary, and I want to export this to a JSON file. As it turns out, you can have dictionaries in JSON files. You can also have arrays. So if I had an array, for example, I wanted to export the SIDs array list up here, that would export to the JSON file just fine. And you can have a list of dictionaries if you want to, or a dictionary that has a list in it, or a dictionary that has a dictionary in it, or a list of lists. All of these things are possible formats for JSON output, so it is okay for you to pass any kind of object like that to the JSON function. Okay, so let's export this. So I'm just going to say with open, and let's go demo/data/ and let's put in, let's output, let's just call it, so we already have grades, let's call it grades output.json, and we're going to open that for writing. We'll just call it output.json. And all I'm going to do is I'm going to use json.dump. Okay, so dump is just going to take any kind of object. It could be complicated or simple. So it could literally just be an integer if you wanted it to. But if it's a list or a dictionary or some combination of those things, then it will figure out a way to turn that into to JSON. Now, JSON is not that different than Python syntax. It's relatively easy to do. Okay, so all I'm going to do is I'm going to pass it the list, no, not names, grades, and I'm going to pass it the output JSON, because this will dump it directly to the file, which is nice. There is a function for converting it to JSON as a string, and then you could actually use the write function to write it to the file. This one writes it directly to the file, so that kind of makes sense. So let's give that a try. All right, so after running that program, you can now see that we have grades output. Now let's take a look, and you see that it's all in one line, and not too surprisingly, that's why these ones are generated by my test run. And you can see that it puts it all on the same line, because the output spaces and tabs and things like that I put into the grades list in the code, the grades dictionary in the code, it was just for my readability purposes. It doesn't really make any sense to have that in the actual JSON file, so it puts it in kind of a compact format. Now, if we want to read that file back, we can do that. Let's call it import.json this time. So let's open it for reading. Okay, so it's called grades_output.json. Come on, autocomplete. Keep forgetting to push escape to get out of that. Okay, so let's actually load the grades. So let's call it list of grades, so that it's not the same as the actual grades array that we used to create it. I'm going to say list of grades. Let's actually call it dictionary of grades. Okay. And I'm just going to say json.load, the opposite of the dump command, and I'm just going to say input.json, underscore JSON. That's going to load it in. And just for the sake of confirming it, let's actually go through. So we'll say for grade in list diction grades. There we go. And I'm just going to print the grade. Let's actually put in an F string. Make it a little bit more readable. Okay. So there we go. You can see, anyway, that it prints each of the grades, which is the key. So I guess what we could do is we could also put grade, and then we'll do something like an arrow, and then we'll say dictive grades grade. Okay, so we use that key and actually look up the value with the arrow. So now it's going to say, okay, this is the relationship between this student ID, there's the grade. Okay, so that's the basics of file loading. Obviously, more complicated file formats are possible, but it doesn't really have a whole lot to do with input and outputting from the file. Now, these examples only include text input and output. Binary input and output is a little bit more complicated. Okay, so let's put in some marker here so we can just say that's for file input and output. Let's do exceptions. So we've got 3 parts. The final part will be the unit testing part. It is a good practice to put your imports up at the top, so let's take care of that too. Okay, so if you need a recap, exceptions are a way for you to, well, it depends on whether you're receiving the exceptions or you're generating them. If you're doing something that potentially could be problematic, and opening and reading and writing from 2 files are pretty good examples of things that could definitely go wrong. Imagine you're reading from a file, the file doesn't exist, the user specifies a bad file name, or the file's not readable by that user, they don't have the permissions, or the file existed, but they ejected the USB drive that it was on. A lot of things can go wrong when you're reading and writing files. And similarly, you know, if you have socket connection or whatever, you can end up running into some issues there. So exceptions tend to occur when you're doing a lot of input and output. So it's one of the reasons why I wanted to focus on it right now. And exceptions are a nice way for you to let the user of your code know that something went wrong. Because one advantage is, like what often happened in older programming languages that didn't support exceptions, is there would be a function, and the function would try to read something from a file. Maybe it would read all of the student data, and then it would calculate the average and return the average. And then if something went wrong, it would try to return some kind of a placeholder value so that you knew there was an error while reading the file. It didn't tell you very much about the error message, and sometimes it was difficult to tell the difference between a placeholder value and an actual value. So for example, like what would you use for an average? You might want to use something like -1 for an average, because it's unlikely that your class average would be negative. But in certain situations, maybe it is possible to have a negative average. So exceptions are better because they're distinct, right? So returning a value from a function is a normal behavior. Exceptions, as their name kind of implies, are for exceptional situations that aren't supposed to happen. Okay, so let's try this code. I'm going to create a list of values. Actually, we already have a list of values up here, names. So I'm going to just copy. It already exists, but just for the sake of clarity, so we can actually see it, what I'm going to do is I'm going to try to print names at position index. Now, position index 5 doesn't exist. This is 0, 1, 2. There isn't an index 5. So when this happens, they're going to get a runtime error. We've seen this before, and we end up getting an index error. Now, it's good, actually, that error happened, because it told me in the console exactly what the problem is. It told me what line to look where the issue happened. It gave me an error message that gives me clues of what happened, right? The list index is out of range. Here's the only list index I have on line 41, so this must be the problem. So clearly it has a value that's just not allowed. So this is great. So I'm not trying to tell you that you should cover up these error messages, but I am going to show you how you can handle these error messages if you wanted to. And then the idea is that you would try to do something to solve these errors. Okay? All right. So the kind of error that we're getting is called index error, and you can see that down here. So I can catch this error by saying, well, try to do this code right here, print names at index, And then in the exceptional case where we do get an index error, let's call that E, like an error variable, then I'm just going to print some kind of an error message that's a little bit more user-friendly. So I'm just trying to handle this in a more user-friendly way. So this was great because for me, I'm a programmer, and this is the exact thing I want to see. I want to see line 41, I want to see what the exception was, and so on. But imagine if something happened that wasn't the programmer's fault. It was the user's fault. Like they typed in a bad file, or they tried to access a file that they didn't have access to, or they tried to access a file on a USB drive, but they ejected the USB drive. Those are all kind of the user's issue, right? Or they're trying to make a socket connection to some website, but their Wi-Fi connection is down. We have to let them know in a nice user-friendly way. So this is not one of those situations right now, but I'm going to use this as an example to demonstrate the process. And of course, normally you wouldn't print to the console for the user. You'd do a pop-up or whatever, but we're not using graphical user interfaces in this class. So anyway, just going to say no such index. And then what I'm going to do is I'm going to just print out the error message as well. Okay, so this is going to like catch the exception. In fact, a lot of programming languages use the word catch here instead of accept. And you can see here, anyway, it prints a message. Obviously very different than the error message that we got. It doesn't have the line number anymore. So for a programmer, this would be a mistake. All we're doing basically is kind of hiding some of the details of the error message. But I have made it more user-friendly. So in situations where it's not a programmer error, this is actually a pretty good solution. This particular thing doesn't match that situation, but anyway. And this is a built-in error. So index error is one of the many errors that you can have. There's divide. You can, for example, do something like 5 divided by 0. If I try to do this, it's going to get me a zero division error. That's another built-in error. So there are built-in errors in Python already. But what if I want to make my own? Say, for example, I'm trying to load in a file, and the user just types in an invalid file name. So I'm making a game, let's say, and they say, well, I saved my game. My game was called January 11, something like that, to remind them when they were playing the game. So I can make my own error. So I'm going to create a new class called invalid file name error. And this could represent a bunch of different possibilities. Maybe they specify an OK file name, but it doesn't exist. Or maybe more likely, based on the name of this class, maybe they try to type in a file name to save their save game, and they've got some illegal characters in there. So, for example, in some systems, you can't have like an asterisk character in your file name, but maybe they put one in there, and this is something I might want to catch. Okay, so now if the user asks for a file name, let's ask the user for a file name. Let's use the input function, which we haven't used in quite a while. So let's say enter a file name for your save file. And all I'm going to do is just check to make sure that the file name is correct. So for simplicity, all I'm going to do is if the user types in too long of a file name, let's say more than 8 characters, so I don't have to type in too much to test this out. So I'm just going to say if the len of the file name is greater than 8, what I'm going to do is I'm going to generate an error. This is called raising an exception. So I'm actually going to generate an invalid file name error. Now the parent class, when I declared this invalid file name, was exception. And exception already has a constructor or an initializer that takes a string. And so I can actually pass this a string to it. And then in this case, I'll make the error file name is too long, for example. And I'm going to raise that exception. All right. Now I'm putting a try except block around this because I also want to catch the error just for another example. So I'm going to catch an invalid file name error as, let's call it error this time. And then all I'm going to do is print. And that was supposed to be an F string, but I forgot the F. So let's fix that. And because this is like a crucial error, I can't do anything, let's actually quit so that it'll immediately quit if I type in something just not allowed. Okay, so now down here, I'm going to type in the save name for our save file. If I just type in ABC, that's fine. It works no problem, no errors. But this time, let's type in more than 8 characters. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 10 characters. In this case, it says, oh, okay, that file name was not valid. Anyway, so there's an example of how you can use exceptions in your program. These exceptions don't necessarily have to be these really technical exceptions. You could have an exception, say you're writing an application to manage your banking on a website, and you want to tell the user, hey, you can't transfer that amount of money because you don't have that much in your account. You could have an insufficient funds error or something like that you raise, and the idea is somewhere else in the program where they try to do something which withdraws money from their bank account to do something with, pay a bill or transfer or whatever, then it would generate the insufficient funds exception, and then presumably that part of the program would turn that into a user-friendly error message saying, yo, I can't pay for this bill because you don't have that amount available in your bank balance. Okay, so let's move on to the final part, which is the unit testing. So remember that unit testing, the purpose of unit testing is to test the individual parts of your program. So I have a function that I'm going to use to test, a couple of functions actually that I'm going to use to test. So let's actually, I'm just going to copy and paste this from elsewhere. Okay, so we've got a function called SumList, which, as its name kind of implies, takes a list of numbers, goes through, calculates the total, and returns the total. And I also have a factorial function, which we've seen before. So a factorial function is going to, return one of the base cases. If n is 1 or n is 0, it's going to return 1. And if not, it's going to return n times 1 less factorial, so n minus 1 factorial. It also has a check up here, just for safety's sake, that's going to check to see if the value of n was negative, because normally I just wrote the code like this, and I'm assuming that my user's not going to provide me a negative n value. But you shouldn't really assume that about users. Users will try things that are kind of off the wall. And so in this case, I've created my own custom exception class called invalid n error, which is very, very specific. Like, it's specifically n is wrong, but there's already an illegal argument error built into Python. So I just decided to make this one for the fun of it. Okay, so if n is negative, then I raise an exception. So we've actually seen this before. All right, we're going to use the unit test framework in Python. So I'm going to import it up at the top. Okay, it's just called unit test. And I'm just going to import it the usual way, so as opposed to import the individual parts. So what I'm going to do with the unit test framework, what you do is you create a test class, okay? And the class has a number of test functions inside it. So our test class is going to be, we'll just call this sample tests, let's say. And I'm going to say unit test.testCase as the parent class. So testCase being the parent class automates the process to make sure that when I invoke a function called main on it, which I don't have to actually define, it's built into this parent class testCase, it's going to look for all of the methods in this class that begin with the word test. And anything that has test underscore at the beginning, it's going to run that just to make sure that it works. So I'm going to have a function. Let's first write a function to test this SumList function here. Okay, so I'm going to create a function called test SumList. And I don't need to pass any arguments to it, so I'll just have self in there. And then I'm going to use one of these asserts. Okay, so I'm going to have, you can see there's a bunch of them. Assert that it's greater than or greater than or equal to, assert that it's false. I'm going to use assert equal. Okay. And basically what I'm doing here is I'm going to pass it 2 values. And if they're not the exact same value, then this is going to generate some kind of an error. Okay, so let's say, for example, I'm going to call SumList. And the first argument I want to pass, the argument I want to pass to SumList is an empty list. And then I just want to compare that the sum of this empty list and 0 are the same exact value. Okay, so that's just a really simple test. Down here, I'm going to just do the main thing here. I'm just going to call unit test dot main, and that's going to invoke the it's going to look through the file for anything that is a child class of test case, and then it's going to invoke all of the functions that start with test. So there's only one, and it only does one assertion. For simplicity here, I should actually disable the code that asks me to enter in a file name, maybe just for the simplicity of it here. It says it ran one test, and then it says OK. So it seems like that test seems to have passed. Not too surprising, I suppose. Well, let's actually just comment this out. We'll just put ABC in there hard-coded, so I don't have to type in that in a bunch of test cases. OK. So that's good. I know that if I pass it an empty list, it seems to generate the right example, so the right sum. So let's do another sum list, and we'll compare that with another value. I'm going to do this a bunch of times, so let's just copy this maybe 3 times. And for the first sum list, I'm going to pass it just a singleton list with just a 1 in it, and so therefore the sum should be 1. And then for the next one, I'm going to make sure 1, 2, 3, and the sum should be 6 in that case. And let's just make sure it works also with negative values. For example, I'm trying to find like different cases. In this case, 1 plus 2 plus negative 3 should be 0. All right, so now we've got more assertions, but still just one test. It's only testing the one function, but it's testing a couple different scenarios. And to me, a singleton list and an empty list and a non-empty list, those are the test scenarios that I think are important. So it seems like that works okay. Let's write one more test class before we finish up here. Let's test our factorial function. So I'm going to do self.assert equal, and there's tons of these options. Obviously, there's other asserts that we could use. I'll show you one more today, but let's just test a bunch of factorials. So for example, we'll do factorial 0. 0 factorial is supposed to be equal to 1. That was hard-coded as one of the base cases. And let's copy that a bunch of times. So let's do it 6 times. And let's actually just test the first 6 factorials. Okay, so 0 factorial is 1, 1 factorial is 1, 2 factorial is supposed to be 2, 3 factorial is supposed to be 6, 3 times 2 times 1, 4 factorial is supposed to be 24, and 5 factorial is supposed to be 120. Okay, so if we run this now, we should actually get 2 tests. It says ran 2 tests. And if I were to do the wrong thing here, for example, let's say I put the wrong number in here, it'll actually give me an error saying, whoa, 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 okay. You tried to assert on line 91 that the answer should be 120, but the actual value is 120. Sorry, the answer is supposed to be 121. The actual value was 120. It didn't match. It'll tell you exactly where. It'll give you a summary at the end of which ones passed and which ones failed. Each of these counts as one test. One more thing I want to show you is how do I test that it throws an exception in certain cases. All I have to do for that is I say with assert raises, self.assert raises, and I'm just going to pass it the exception, invalid n error. That's the exception it's supposed to raise. So I'm just going to say, well, the code that's inside this with clause must generate an invalid n error. I want it to validate that. And if it doesn't, then this assert raises will actually fail. So it'll cause the test to fail. So I'm just going to say result equals factorial of -1. It doesn't matter what the result is, so I'm kind of ignoring the result. But in this case, this should pass because we did in fact get the error. And if I comment out these 2 lines of code, it won't generate the error. And you can see anyway that we get some errors here. And this one actually will cause big problems because it doesn't. It's actually supposed to do something. Let's actually just have it return instead of do the exception. So in this case, it doesn't do infinite recursion, but the assertion error does fail because we didn't raise the exception as we were supposed to. Okay. back to the way it was, and all of our tests pass. So usually what you do is you write a class, and the class has a couple of functions in it, and then what you do is you, for each of the functions in that class, you create a test class that corresponds to it. So let's say my class is called customer. I'll create another class called customer tests, and that'll derive from test case. And then for every function in the customer class, I'm going to have test underscore and then that function name. And I'm going to have a bunch of assertions inside here that are going to test that function in all different ways that I can think of. And if I think of all the possible, like I don't obviously, like 1, 2, 3, summing 1, 2, 3, and then summing 1, 2, 4 isn't really going to tell me anything super new. I'm pretty sure it's adding properly. I didn't miss the first element. I didn't miss the last element. And just what the numbers are isn't as important as how many numbers there are. So I think I've handled all the major test cases, and I wasn't sure if it would work with negative numbers, so I added one more. But I'm pretty confident that I've tested this in all different aspects. Same with factorial down here. I handled the base cases, I handled the recursive cases, I handled the exceptional cases, and I think that all of the different situations are possible. Yes, I could test factorial 6, but I don't think it's really necessary for me to do that. Anyway, so hopefully these examples were enough to help you get started, and you can use this as a template for your future code file access, or generating your exceptions, or running unit tests, including testing for those exceptions. All right, so I'll see you next time.